Okay, so now after we've got all of these Bromley survey forms filled in, so let's say we had to go and sample 5 sampling plots. Now we've got 5 of these forms, all of them filled in per site, and now we basically have to go and start and process or analyze these forms. We have to start working with the data that has been captured to ensure that we get to results, and essentially we know that it should be to get to the resultant vegetation communities that are classified and not necessarily now only initially stratified. So basically to get to the end product. So we're sitting with a couple of these Bromley survey forms that has been filled in. Now what do we do with this? So what we do is we need to compare firstly all of the primary data that we've captured, and then assisting the primary data would be the secondary data. But still, usually we only have to make use of the primary data to classify or differentiate one community from the other one. On CA Connect you will find that there's a classification form that you can make use of. This is an adopted one, so I mean you can go and chop and change on this if you really want to, especially now in your third year, whatever applies to your circumstances and situation. But this is a nice one to go and practice off of and see as an example of what type of processing can occur. Now obviously we're not going to use, and this specific now to your second year, we're not going to use massive data sets. You know, we didn't go out and all of a sudden do 80 various sampling sites across the study area. Instead we did a couple to be to a certain extent subjective but representative as well of the specific vegetation, initially stratified vegetation unit. So it's easy to work with this on this scale, but please do be aware that once you go and have massive data sets and you identify absolutely every species within the sampling plot, not just the dominant or some diagnostic species, but absolutely all of them, then what happens is it becomes overwhelming, the amount of data that you have to work with when differentiating communities from one another. So we've got options. Usually you can go and in the olden day they just printed it out and they tried and compared the symbols to one another and then ordinated. We call this whole process ordination, according to whatever is seen as dominant symbols and not, and then further ordinated from, you know, into not only communities but sub-communities, etc. But this is essentially what we're doing now with this form that you're seeing in front of us. Is a manual means of doing it, but you can actually go and process the data within computer software programs such as PhytoTab, and there's MegaTab and some other programs like that as well, if you want to go and make use of them. But nonetheless, for the sake of the data that we're working with currently, you can go and do the ordination manually and then obviously the differentiation as well. So you'll see that's sampling plot 1. So this will depend now on how many sampling plots. So let's say for argumentative sake we've got 4 sampling plots that we did. So maybe we had 4 initially stratified communities or stratified units. So we went and did 1 sample site per stratified unit, and we do know that if it's standardized we cannot only go and do 1, we at least have to do 3 or 4 within each stratified unit. But for time's sake now we are only able to do 1 per identified or stratified unit. So you take the 1 Bromley form and you go and take the relevant data that is asked of you and you fill it into this form. So it's going to say what was the dominant stratum: tree, shrub, dwarf shrub, grass, forb. Which one was that? And then give me the 3 dominating species in the plot. Give the species name. and this is the cover abundance percentage as well. And then of each one of those, give me the specific growth form, and then give me the total amount of species that was identified. If you identified only the 5 or the 10 dominating species, I mean, that is on you. So essentially this is not really going to make sense if you then give me a specific number over here of how many species occurred. But we can make use of this to go and differentiate between various communities as well. So if this one within this plot and you identified absolutely every species that you could find, and that was now plants, then maybe in this plot you got to 25 species, and to this one you only got to 6 species. So yet again, I mean, it's a component that can be used to differentiate this one from the other one. And then you've got a diagnostic species, a species that you've identified that does not occur in any other. So it's unique to that community or that stratified unit, and it does not occur in any other unit. Yet again, I mean, if you go and identify all of the species, it will become more clearer. You then fill in all of the secondary variables asked of you as well, the rock percentage cover, erosion percentage, trampling aspect, slope, terrain, morphological unit. And you can then even go and further work with this, especially when you come to a form of alien invasive management plans or sensitive species or conservation plans. Then you can go and fill this in: protected species found in the plot with the cover percentage, and then invasive species found in the plot with the cover percentage. This is just additional information that you are going to work with once you're done with the classification and you start focusing in on the management of certain groups of species, like we said, maybe your alien invasives. It's also a means by where you can identify where these alien invasives and where these sensitive species occurs. Okay, so you fill that in for each stratified unit. For each form you've got, you go and fill it in. Once you've got this, then you can go and start and compare them with one another. So in other words, go and look at the 3 dominating species. If stratified unit A, the 3 dominant species are in correct order similar to this one, which is stratified unit B, then you can say, okay, well, we cannot say that these 2 are different from one another. Then you go to the next level. So you say cover abundance scale. So if there's a cover abundance percentage for each one of these as well, do they look similar in density, yes or no? And then obviously you can go and look at whether the growth forms differ. So if they are exactly the same, all of the growth forms for the 3 dominant species, then we can most probably say that, listen, these 2 are going to be exactly the same vegetation community. Let's include them as one when we classify them. So yes, they've been stratified as unit A and B, but they're classified as, say, unit A, vegetation community A. Okay. And if you still do not want to accept this, then we can run to the next cascading level as well. Okay, rock percentage cover, no, they are still the same. Erosion percent is still the same. Trampling still the same. All of these things are still the same, and that is why we regard them then as being still only one vegetation community instead of 2 stratified units. After we have then differentiated the various communities from one another, we need to go and describe each one of these communities. So this is an example out of one of the papers that we previously worked out of, and this community is called Foria saligna setaria spacellata open woodland. So essentially there's 2 species names and then a descriptive term of the specific habitat structure to a certain extent as well. So where do we find that descriptive word, and where do we find these 2 species. Now if you go to Edwards, go and read through the specific paper, a broad scale structural classification of vegetation for practical purposes. Once you scan down to the lower lying pages, then you'll see that there's various height classes that they start to give you, and various percentages of cover, and what descriptive term is given those. As an example, 10 to 100% canopy cover percentage you would maybe mention as being closed, and then you get an open and sparse and a scattered as well. There's some subdivisions as well, but once you get maybe down to this table, you can make use of it quite effectively in giving that descriptive term. So here it gives you the dominant height class. So you take that specific dominant structural height class, and let's say it is a tree, and that tree of more than 20 meters had a percentage cover of, let's say, 60%. So if we go down this, it says 75 to 100%, it says 10% to 75, 1% to 10, and 1 to 0.1. So we said at 60%, so it would be considered a high closed woodland. And obviously we can go and look at the other dominant growth forms as well, shrubs and grasses and herbs, and look maybe at their specific sizes as well. Maybe we haven't even classified or discussed the various grasses to such an extent, but still, I mean, we can actually then go and quite successfully still look at the percentages cover if need be, or you can just say it's a grassland. Okay, and then just with regards to the discussion, so we've got all of the information at hand now. We've differentiated, and just to mention what the species names within our labeling of that specific community should be. Usually there is a specific nomenclature to this, phytosociological code of nomenclature, but if you keep to the dominant species and the subdominant, it's acceptable. And if you keep to the dominant species as the first name within this label, and the diagnostic species as the second one, that is acceptable as well. So let's just quickly look at the general discussion. So this woodland is located on gentle slopes of rocky outcrops flanking the central drainage channel of the study area. This low-lying community comprises of 133 hectares and has an altitude of approximately blah blah above sea level. You've got a nice picture that is representative of that study site as well, or that community. And then these areas are mostly representative of the various land types. If you've recorded that as well, you go and describe common species that is seen. You can include the amount of plants per hectare or individuals per hectare, and you can discuss the sensitivity and the woody layer cover. You can discuss any form of alien invasives within that area. And so on and so forth. So this is basically the resultant product. Firstly, you've got a map that shows you the various vegetation communities, and then you have a description of each one of those identified, classified vegetation communities.